6-3, proving that a quadrilateral is a parallelogram. Now, this video is going to look a lot like last night's video. The difference from last night is I gave you a quadrilateral and told you it was a parallelogram, and then said, here's all this stuff we know. Okay? What tonight's video is here's a quadrilateral. Let's see if it's a parallelogram or not. All right, so I'm going to show you ways to prove that a quadrilateral is a parallelogram, even if they don't tell you it is a parallelogram. Okay, but like I said, it's going to seem really similar to last night's video, but you still need to watch it. All right, first of all, here is a quadrilateral. Okay, let's call it quadrilateral ABCD. All right. All right. Now, if I gave you this quadrilateral and I told you that this side was congruent to this side and this side is congruent to this side, okay? Just knowing this little bit of information, this is enough information to say A, B, C, D. Okay, that's how you write a quadrilateral. There's no symbol before it. It is a parallelogram. All right, just knowing that opposite sides are congruent, okay, is plenty of information to qualify this as a parallelogram. Okay, because if you remember from last night's video, parallelograms have opposite sides not only congruent but parallel. Okay, so this is enough information to prove that quadrilateral is in fact a parallelogram. Alrighty, let's move on. So here we have another quadrilateral. I'm not going to call it a parallelogram. Here we have another quadrilateral. Now, I say you saw this and you saw that, I don't know, let's call it ABC again, ABCD. And you saw that this angle plus this angle, all right, so the measure of angle A plus the measure of angle D equaled 180. Okay, and you also saw that the measure of angle A plus the measure of angle B also equaled 180. All right, so these two angles add up to 180. These two angles add up to 180. That alone, right? That alone, even without knowing the measure of C, this alone is enough information to prove that A, B, C, D is a parallelogram. Spell that wrong. All right, because if you remember from last night's video, consecutive angles, okay, consecutive angles share a side. Consecutive angles are supplementary. Okay. So if you're given a quadrilateral and you can prove that two consecutive angles, as long as they share one of those angles, like in this case A and D, and here we have A and B, so A is supplementary to both of its consecutive angles. That is enough information to prove that your quadrilateral is in fact a parallelogram. All right. Now let me give you one more case, and then I'm gonna give you some problems. All right. So here we have another quadrilateral. Again, I'm not saying it's a parallelogram, but if you looked at this quadrilateral and you saw that opposite angles, so angle A and angle C, angle D and angle B, are congruent. Okay. So angle A is congruent to angle C, and angle B is congruent to angle D. This alone is, again, enough information to prove our quadrilateral a parallelogram. Okay, so A, B, C, D is a parallelogram. All right, so let's try some problems here. So here we have another quadrilateral. Oops, come on, grab it. There we go. All right, this top side here is 3x minus 5. This bottom is 2x plus 1. This side is x plus 2. And this side is y. What we want to do is we want to find the values for x and y that make this a parallelogram. How are we going to do that? Well, in order for this to be a parallelogram, we know that opposite sides, because we don't have angles, so we have to concentrate on the sides. We have to prove that the opposite sides are congruent. Okay, so we need to prove this side's congruent to this side, and this side is congruent to this side. So we're going to have to solve for x to prove that these two sides are congruent. So 2x plus 1 equals 3x minus 5. And we also know that x plus 2 equals y. This is obviously the most logical one to solve first because this one has two variables. And once we solve for x, we can just plug it in, add 2, and get y. So let's subtract the 2x minus 2x plus 5 plus 5. So 6 equals x. So since x plus 2 is y, that means y equals 8. Okay, so as long as x is 6 and y is 8, our quadrilateral here is a parallelogram. All right, now I want you to try one. All right, I get our parallelogram here. Sorry, our quadrilateral because we're not 100% sure. This angle here is 3y minus 2. This angle over here is 4x plus 13. This angle down here is 12x plus 7. This angle over here is y plus 10. All right, what I want you to do is prove that this quadrilateral is find the values of x and y to prove this quadrilateral a parallelogram. All right, so pause the video and figure it out. Okay, so we know that in a parallelogram, consecutive angles have to equal 180. All right, so we know that these two angles here, these are consecutive angles. We know they have to be supplementary, so they have to be 180. So 3y minus 2 plus y plus 10 will have to equal 180. All right, so now we just got to combine like terms and solve. So 4y plus 8 equals 180 minus 8 minus 8. 4y equals 172. Divide 4. Divide 4. And 172 divided by 4. So y equals 43. So now we can plug that back up into here. Y plus 10. So y is 43. So y plus 10 is 53. Okay. And up here, we have 3y minus 2. Well, 43 times 3 is 129. Minus 2 is 127. And of course, 127 and 53 is in fact 180. All right. So now what we have to do is we have to find the value of x, so that 4x plus 13 and 27 equals 180, or we can do the 53 and the 12x plus 7. I'm going to do the 127 plus 4x plus 13 equals 180, because that has to be the case as well. So combine our like terms. 4x equals 140. I'm sorry, plus 140, because 127 and 13 is 140. And that equals 180. Subtract the 140. Whoops. So 4x equals 40. So of course x equals 10. So now we come up here. 4 times 10 is 40, plus 13 is 53. All right. So now we've proved these two supplementary, and if you look, our opposite angles are now congruent. Okay, and since we've already found x, we can sub it in here just to verify that this does equal 127. So 12 times x is 10. 12 times 10 is 120, plus 7 is 127. Look at that, it works. So therefore, this, as long as y equals 43 and x equals 10, our quadrilateral is a parallelogram. All right. Now I'm going to show you a couple more ways to prove quadrilaterals are parallelograms. Okay. So here we have a parallelogram, and let me draw in the diagonals. So you remember from yesterday's video, the diagonals of a parallelogram bisect each other. But in this video, we don't know that our figure here, our quadrilateral, we don't know it's a parallelogram. All we know is it's a quadrilateral because it has 4 sides. But if we have our diagonals drawn in like we do here, and you notice that the diagonals bisect each other, okay? So this segment is congruent to this segment, and this segment is congruent to that segment, whether they have the tick marks like this, or they actually have numbers, say that's 4 and 4, and say this is 3 and 3. All right. So whether they have numbers or the tick marks to show them congruent, that is enough information to prove that this is a parallelogram. Okay, so quadrilateral ABCD, so ABCD is a parallelogram. I'm going to say paragram. I don't feel like writing it. All right. So just because we know the diagonals bisect each other, okay, that's what this picture shows, because I'm going to put an E here, because BE is congruent to ED and AE is congruent to EC. That is plenty of information. That's all we need. We don't need anything else. We don't need to know that opposite sides are congruent. We don't need to know they're parallel. The fact that we know the diagonals bisect each other tells us that it's a parallelogram. So now we know opposite sides are congruent and parallel. Okay? And the last way, you're probably jumping for joy. All right. Now the last way. So here we have a parallelogram. Say that we only know that one pair of opposite sides is congruent, and that same pair is also parallel. Okay? So one pair of sides is both congruent and parallel is enough information. Okay? So A, B, C, D. All right, since AD is congruent and parallel to BC, we know that ABCD is a parallelogram. Forgot my R. There we go. Okay. Just because we know that these two sides are congruent and parallel, we know that this is a parallelogram. All right. Now let's do another U try. Let me paste in our quadrilateral here. All right, so we know these two sides are parallel, and this is congruent. All right, so the question here is quadrilateral ABCD a parallelogram? Is ABCD a parallelogram? All right, so go ahead and pause the video and figure this out. Is this a parallelogram? All right, so is this a parallelogram? If you said no, we do not have enough information to prove it. You are correct, because if you remember from the previous slide, we need to know that that one pair of opposite sides is both parallel and congruent. We know that these two sides are parallel, and we know these two sides are congruent, but it needs to be the same pair of sides, parallel and congruent. So instead of AB being congruent to CD, if it was changed to this way, this would work. It would be a parallelogram. Or, remember we knew these sides were marked congruent from the beginning and the top and bottom were parallel. Well, if we knew that these sides were parallel as well as congruent, we would also, again, have enough information to prove it a parallelogram. But since our picture had one pair parallel and the other pair congruent, we do not have enough information. Not enough info. Okay, we do not have enough information to prove this is a parallelogram. Because remember, in geometry, unless you're told specifically that your diagram is drawn to scale, you have to automatically assume it is not drawn to scale. So even though this looks like a parallelogram, you can't assume that because it looks like one, it is one. All right. So here is your ticket in the door. It says, for what value of y must LMNP be a parallelogram? For exercises 2 and 3, is the given information enough to prove that ABC is a parallelogram? Make sure you explain your reasoning. Number 4, it says explain why you can now write a biconditional statement regarding opposite sides of a parallelogram. Yeah, I don't want you to do that one. Forget about that one. How is the theorem 611 in this lesson different from 6.6? No, because I don't give theorem numbers. I don't like theorem numbers. And number 6 says, your friend says if a quadrilateral has a pair of opposite sides that are congruent and a pair of opposite sides that are parallel, then it is a parallelogram. What is your friend's error? Explain. All right, so make sure you complete these 4 problems. Have them ready to go when you come in the room tomorrow. Good luck.